Hello, everyone. I wanted to make a quick video to help with the word problem here in Module 7. So I wasn't able to get to this one in class. There's just not enough time, so I wanted you to have a video to help with this, one. Okay, so the a paddle wheel on a riverboat turns as the boat moves through the water. The vertical distance between a particular pattern on the wheel and the surface of the water is recorded. So the vertical distance d in meters as a function of time t in seconds is shown in the graph. And we have to answer some questions. Okay, so we've got a riverboat. You'll have to forgive my drawing skills here. I am not an artist. So we've got some kind of a riverboat here, and it has a paddle wheel on the back, right? So there are paddles on that wheel that spin, and that as it spins, those paddles push the water, and that's what moves this boat along, right? And so this wheel is spinning in circles. And so if we just look at one of these paddles, how about this one right here? If this is the paddle that we are looking at, then when it's up here all the way at the top, we'll be at the top of a wave, right? This is when it's going to be the highest above the water. And then as it turns, when it's over here on the side, we'll be in the middle. Let's see, try to find the middle of this graph. This is up at 16. The bottom here is -4. So halfway between these guys is going to be 10, right? No, not quite. Just kidding. It's not going to be 10. It's going to be, let's see, 16 minus 4. You'll add them together and divide by 2. 16 minus 4 is 12. Divided by 2 is 6. Here we go. This is the midpoint of this. So when it is at the side here, when the paddle is at the side, we will be down here at 6. Meters above the water. When it's all the way down here on the bottom, we'll be down here at the very bottom of this rotation, which is -4 meters above the water, which means we're 4 meters below the water. And then when we're back over here, that would be when we're back here at the midline. And then when we come back up to the top here, we would be back up here at the top at 16 meters. Hopefully that starts to make sense. So as this paddle spins around this wheel, this graph shows us how high above the water that paddle goes. And again, we're just picking one paddle and following it. Okay, so that's what this graph is showing us. And then what is the period of the graph in seconds? Okay, so the period is how long it takes us to go from the start of one cycle to the end of one cycle. So let's just say we start here at 0. When do we get to that same place in the wave and repeat this pattern? Well, the next time we get to the top of a wave is here. And after that, we repeat the same pattern as before. So this is where we end that first cycle. Since we started at 0 and we end at 12, that means that our cycle is 12 units, and here our horizontal units are seconds. So the period of this graph is 12 seconds. That's this horizontal distance from the start of one cycle to the end of one cycle. That is 12 seconds here. So that's my period. Okay, so which of the following best describes the period of the graph as it relates to the paddle wheel? The number of meters from the center of the paddle wheel to the paddle's maximum vertical distance from the water's surface. Well, that can't be right because my period is measured in seconds. So this isn't going to tell me a number of meters. So it can't be that one. The number of times the paddle goes around the paddle wheel. Nope, it's not the number of times we go around. This again, it takes 12 seconds to complete this whole pattern. So it's not a number of times, it's an amount of time. So that can't be right. The number of seconds it takes for the paddle wheel to make one revolution around the paddle wheel. Yes, right? So here at the start, we're up here at the top. By the time we end, we've gone all the way around and we're back where we started to repeat that pattern. It is the number of seconds, just fill it in here, the number of seconds it takes for the paddle wheel to go all the way around. The number of meters, again, it can't be a number of meters. This is measured in seconds. Okay, so that's what our period tells us. It tells us how long it takes for this paddle wheel to go all the way around. What is the distance in meters between the center of the paddle wheel and the surface of the water? Okay, what is the distance in meters between the center of the paddle wheel and the surface of the water? Okay, so let's find the center of the paddle wheel. Where is this? Well, the center of the paddle wheel is right here, right? That's going to happen at the midline of this whole thing because that's when we're like halfway through, we're halfway down to the bottom and we're halfway back up, right? So the midline is going to happen at the vertical halfway point. That's where the middle of this wheel is. And we found that the midline of this whole thing was 6 meters. So the center of the paddle wheel is right here. Okay, so the center of the paddle wheel is at 6 meters. Let's see, a paddle wheel moves through the water. The vertical distance between a paddle wheel and the surface of the water. So really, this distance over here is the distance between the paddle and the surface of the water. So a height of 0 is when we are at the surface of the water. So this is the surface of the water down here. So the center of my paddle wheel is 6 meters above the water. And the surface of the water is at y equals 0. It's when we're 0 meters above the water. So what's the distance between 6 meters above the water and 0 meters above the water? The answer is it's 6 meters, right? This distance here, this 6 meters, this is the distance between the center of the paddle wheel and the surface of the water. It's 6 meters. Hopefully that makes sense. And then relative to the surface of the water, what is the height of the paddle in meters at t equals 42 seconds? Use a positive number if the paddle is above the surface and a negative number if the paddle is below the surface. Okay, so we want to know the height when t is 42. Notice that t equals 42 is not on my graph, right? This only goes up to 21. That's not enough to get me to 42. So how will I know what the height at 42 is? Well, we're going to have to use the pattern, right? This pattern repeats every 12 seconds. That's how long it takes for this paddle to go all the way around. So since we repeat every 12 seconds, then wherever we are at t equals 42, the position there is the same as it was at t equals 42 minus 12, 12 seconds before it. It was at the exact same spot. And so 42 minus 12, that's 30 seconds. That's still not on my graph. So I'm going to have to do it again. That position at t equals 42 seconds is the same as t equals 30 minus 12 seconds, right? What if I went back another rotation? So 30 minus 12, that's 18. So wherever the paddle is at 42 seconds, is the same as where it is at 18 seconds. 18 seconds is in fact on my graph. The height of the paddle wheel above the water, it's right here at -4. So we are -4 meters above the surface. Again, it says a negative number if we're below. We're 4 meters below the surface. We're at -4 meters. So what we're doing here is we're kind of using that idea of coterminality to say, oh, this is at the same spot as we were if we went back a period. And our period repeats every 12 seconds. So that's why we're subtracting this 12. We're basically doing our coterminal parts, but it's every 12 instead of every 2 pi. So we're subtracting that 12 to figure out where we came from. Okay. I hope that helps with this one. Have a wonderful spring break, and I will see you in class on Monday the 18th.